everyone, today we are going to be talking about piecewise functions, and we are going to start by first defining what a piecewise function is. We are going to say that a piecewise function is a function made of smaller sub-functions. And so let's look at what we mean by that. So looking at the graph we are given on the right, we can see that there are three distinct pieces to this graph. And so what we're going to first do is write the full function for each piece. So starting with this line here, if I were to extend this out, we now know the y-intercept is at 5, and we know the slope is 1. So those are the only two things I need in order to write the equation of a line. So I know that the function here is y equals x plus 5. Now, looking at the second piece, I have a parabola. And so what I need to know for a parabola equation is the vertex, which is -1, 2. And I need to know if there are any vertical stretches or shrinks, which there are not, because my three key points form that little V shape. And the two extra points besides my vertex are not shifted up any extra besides 1. So I don't have any vertical stretch here. As soon as I know that, I can say that y equals x. And in order to shift to the left 1 with my vertex, I have to add 1, because I want to do the opposite for horizontal transformations. And then I need to add 2 to accomplish the shift up 2 that I see. And the last piece of this function is this absolute value graph. Again, like with a parabola, I need to know where the vertex is, which is the point, let's see, 1, 2, 3, 4, 5, 6, -1, and any vertical stretches, which again there are not, because my three key points are in the same spot as they would be on the parent function. So, combining this, I know that my equation here is y equals the absolute value of x minus 6 this time, because that will get me to shift right. I want the opposite sign. And then -1, because my vertical shift will match signs. Now, when we are working with piecewise functions, we are not going to be using the full function for each piece. We are going to have to restrict our domains, because right now everything I have drawn on this graph does not pass the vertical line test. So technically, this is not a function right now. So I'm going to erase everything that I added, and now we are going to talk about the domain across each section. So the domain for my line goes from -infinity all the way to -1, 2, 3. And because I have a closed circle at -3, I'm going to put a bracket around -3. My parabola goes from -2, and since -2 has an open circle, I'm going to put a parenthesis around it, all the way to x equals 1. That is the domain of the green portion. And lastly, the absolute value function goes from 2, an x value of 2, and since it has a closed circle, we will put a bracket around it all the way to +infinity. We always put parentheses around infinity. So we need to combine what we know about functions and parent functions and transformations and what we know about domain in order to effectively write the equation for a piecewise function. This is what a piecewise function looks like. So we are going to be using interval notation when we are denoting which pieces we want where. So the first part is a parabola. F of x equals x minus 5 squared. That signifies I have a parabola. Minus 2. what we want to do is first graph this function as is, and then we will erase the parts that we do not need. So my vertex for the parabola is at positive 5, negative 2, because I want to switch the sign of what's inside my parentheses. So I go to positive 5, 1, 2, 3, 4, 5, and down 2. And this is my vertex here. Now I don't have any vertical stretches because I don't have a number besides 1 out in front of my parentheses. So I know that I'm going to have this point and this point here as is. Now, when we are sketching this graph, we don't have to be exact. However, we do want to pay attention to our interval. So I know that I'm going to be doing everything to the left of negative 3. That's what I'm going to keep. So it's going to be really important for me to get an accurate value for x equals negative 3. So at negative 3, I'm going to evaluate it. So I'm going to say f of negative 3 equals negative 3 minus 5 squared minus 2. So that's going to give me 8 squared, technically negative 8 squared, which is 64, minus 2 is 62. So that's going to be way, way off of our graph. So I'm just going to sketch this in, and we're not going to worry about it too much, because that's just way off the charts. And then they tell us that our function equals 2 if x is on the interval from negative 3 to positive infinity. Well, the equation f of x equals 2 is kind of a tricky one, even though it's pretty straightforward. Really, what this is a perfectly horizontal line at a y value of 2. So once I establish this, now my job is to erase everything that I do not need. I already said that for my parabola, I want everything to the left of negative 3. Well, I'm not going to be able to see that on my graph, so I'm just going to get rid of all of this green, because now I don't care about this parabola unless it includes x values between negative infinity and negative 3. And then for my red function, this f of x equals 2, I only care about from negative 3 to positive infinity. So I go to negative 3, my x value negative 3, and I get rid of everything to the left because I only want everything to the right. Last thing I need to do is make sure that I put an open circle at x equals negative 3, because in my interval notation, x is greater than negative 3, not or equal to. So we do not include negative 3 on this graph. We represent that with an open circle. Here's another example. It's a little bit more complicated, but nothing we can't handle. So once again, we are going to graph everything and then erase what we do not need. So to start, negative x plus 1 for this interval. So again, we will graph the function first and then get rid of what we don't need. So negative x plus 1, I know my y-intercept is at 1, and negative x, I know, means as I move to the right, I move down, and specifically increments of 1. Once I know that, I can create this line here. Again, it doesn't have to be exact, you get the idea. So now I need everything to the left of negative 4. So I'm going to start erasing my line until I get negative 1, negative 2, negative 3, negative 4. And so now, last thing I have to do is make sure I emphasize this is a closed circle, because negative 4 is included. We have an or equal to. Next function, f of x equals 5. So this is a perfectly horizontal line at y equals 5. 1, 2, 3, 4, 5. right here. Now, I only want this function from -4, which we already said was right here, to 0. And since I do not see or equals to, I'm going to make sure that I have 2 open circles. Next function is -√x plus 5. So my square root function looks like this. However, because of the negative, I need to flip it upside down and shift up 5. So we are going to be here, and we are going to look sort of like this. And that's going to be from 0 to 4 is what I want to keep. And specifically, I need a filled in circle at 0 and an open circle at 4 to match my interval notation. And the last piece is a parabola. So for this parabola, we are going to plot the vertex, and then we are going to erase what we don't need once we get our general U shape. So my vertex is at the point 4, 3 because I need the opposite of my inside sign. So I go over 4 to the right, up 3. So that happens to be this point here. And then I'm going to sketch in my parabola. I'm not even going to bother putting in the left side because I want x values from 4 to infinity, which is to the right. And there you go. This extremely weird looking graph is our function. Now, not only can we graph, but we can evaluate the piecewise function using substitution. This is actually probably easier than graphing. The only thing you have to do is figure out which part you must plug into. So for f of 0, first, which interval does 0 fit on? Is 0 less than 2 or is 0 greater than 2? Well, 0 is less than 2, so I'm going to plug in f of 0 into the top part of my equation. So 2 times 0 plus 5, because 0 fits in to this part here. And once I do that, I evaluate. 2 times 0 is 0, plus 5 is 5. Now f of 8, since 8 is greater than 2, I'm going to use the bottom section. So for f of 8, I'm going to say this equals -3 times 8. I'm using the bottom portion. -3 times 8 is -24, and that is my solution there. The last one, f of 2, ask yourself, is 2 less than 2, or is it greater than or equal to 2? Hopefully you said greater than or equal to 2, because it is equal to 2. So f of 2, I'm going to choose the -3x function, which gets me -6. Some more examples here. For f of -4, I want to choose to plug into the top part. So -4 cubed is -64, because -4 times -4 is 16, times -4 is -64. f of 0, 0 is less than 5. So again, I want to plug into the top portion, which gets me 0. 0 cubed is 0. 5 is greater than or equal to 5. It is equal to 5. So I'm going to choose to plug it into the bottom portion. And same thing with 7. 7 is bigger than 5. So I'm going to plug it in here. Your job is to try this part. Let me know if you have any questions. Thank you for watching, and I hope you have a wonderful rest of your day.